I'd now like to show you another application in the context of data streams. Let's say you want to count the number of distinct customers that have bought products in a large online store such as Amazon. For now, assume that you receive the information on transactions as a data stream, which identifies the customers with its customer ID. Here you'd want to use hashing again to approximate the number of unique users. You use the property of hashing where inputs are distributed randomly among a defined number of buckets. Assume that you have a hashing function h that maps each user ID to buckets 0 up to b-1. You initialize each bucket with a value of 0. When a new transaction arrives, we take the customer ID of the transaction, hash it, and mark the corresponding bucket with a value of 1. You can use the number of buckets marked by 1 in order to estimate the total number of distinct customers. Let C be the number of buckets that are marked by 1. Then we estimate the number of distinct customers by B times ln B divided by B minus C. For example, if B is 8 billion and you see C buckets with a 1, you would estimate the number of different customers as 8 billion times ln 8 divided by 7, which is roughly 1.1 billion. If you see 6 billion buckets marked as 1, you would estimate the number of distinct customers as 8 billion times ln 8 divided by 2, which is roughly 11.1 billion. If all the buckets are marked as 1, you estimate the number of buckets as 8 billion times ln 8 billion, which is roughly 182 billion. The principle behind this estimate is related to the coupon collectors problem, and you will learn about this after you have completed this video. Another approach to estimate the number of distinct customers can be obtained by the Flageolet-Martin algorithm. Here you hash each transaction to a bit string of length n, where you choose n appropriately for your application. As hashing distributes elements uniformly at random, you look for unusual strings produced in order to estimate the number of different elements. You can define as unusual a string that ends with many 0 bits. You call the number of 0 bits at the end of a bit string the tail of this bit string. During our process, you record the maximum tail length that you have seen. The probability of seeing a tail of length t is 2 to the power of minus t, as the last t bits all have to be set to 0. So if t is the maximum tail length you have seen, you can use 2 to the power of t as an estimate for the number of different users that have contributed to your stream. Now you are able to count the number of distinct elements in your stream. Next, you will see some further details about both methods and analyze their behavior.